Okay, let's do some practice problems where we balance an equation, but this time without the images of the pictures that I've drawn. And there are two ways of doing this. The first method we're going to go over is the guess and check method. So I'm going to color code each of the steps and make sure you have the steps written down as well. So step number 1, I'm going to split the reactants and the products on both sides. So before the arrow are my reactants. After the arrow, those elements or molecules are my products. In my second step, I'm going to count the number of elements on each side. So I see 3 capital letters on the reactant side or before the arrow: C, H, and Cl. I'm going to use the subscripts, or the number to the bottom right, to count out how many elements I have on the reactant side. So for C, I have just 1 because there's no number written on the subscript. For H, I have 4 because its subscript is 4. For Cl, I have 2. On this side, I should have the same exact elements, C, H, and Cl. Notice I wrote it straight across, and that's just going to help me compare later on. So here's C, H, and if you notice, Cl is split up between the 2 products. Right? So I need to pay attention to how many Cl's I have total. In fact, let's do that first. So Cl, I have 4 here, and there's no subscript here, so I have 1. So I have 4 from here, plus the 1 Cl here, so a total of 5. How many H's do I have? Subscript is nothing written, so it must be 1. C, how many C's do I have? Subscript is nothing written, so I have 1. So my goal for this is to make sure that the elements before the arrow are the same numbers as the elements after the arrow, just like I did with Mg and O2, right? So 2 Mg's before the arrow, 2 Mg's after the arrow, 2 O's before, 2 O's after. Okay, so how do I do that? The only way I can do that is by changing the coefficient numbers. So in step number 3, I'm going to pick one of these 3 elements to start. A tip is that I pick the elements that aren't the same but are easy to work with. So I'm not going to pick Cl because this Cl is split up between 2 molecules. That makes things a little bit difficult. But H, however, H is in just one molecule before the arrow or on the reactant side. H is also in just one molecule after. So I'm going to pick H to balance or make the same on both sides first, right? So I'm always going to start with the side that has less H's, and I'm going to continually add more. So I want the total amount of H on this side to match the H's on this side. So essentially, I want the total number of H's to be 4, right? And currently, I just have 1 as shown here. So I need to think to myself, 1 times, what can I put in the orange box to equal 4? Well, 1 times 4 is 4. Right, so if I put 4 up front, then I'm going to have 4 H's. Right? But notice that it's also going to change the number of Cl's I have. Just like when I added one more O, I had to add Mg and O together. So I ended up having two MgOs and then two Mgs. I had to fix that later on. Right, so basically my Cl is also going to change. So here I have one Cl times 4. Right, so that's going to be 4. And don't forget the other 4 Cl's here. So crossing this out, the 4 Cl here, 4, plus the 1 times 4 Cl's I have here. Let me just make that clear. Right, so 4 plus 4 gives me a total of 8 Cl's. Right, so I have 8 Cl's on my product side. I want to have 8 Cl's on my reactant side. So again, I'm going to figure out what can I change my coefficient to. So currently I have 2 Cl's times what to make it 8 to match this side. Right. So 2 times what equals 8? Well, 2 times 4 will be 8. Right, so now I have 1 Cl on both sides, 4 H's on both sides, 8 Cl's on both sides. So the parts where they are blank, that's just going to be 1 and 1. Right. So in step 4, it's kind of just doing step 3 over and over again until all of the elements match on both sides. So this is one way of solving it. There's a second way, which I'm going to show you next, and that second way requires slightly less math. Okay, so the second way I'm just going to call a drawing method. This is a really informal way of solving it. Feel free to choose either method that works for you. So step number 1, I did in all 4 of these colors, and that is I wrote out each reactants and products below. So right now, the way it's set up, right, I have one CH4 and I have one Cl2, one CCl4, one HCl. Then I'm going to draw a line to separate my reactants and my product side just like I did before. Right. So in step 3, I'm going to pick one element either on the reactant side or the product side. Doesn't have to be the reactant side, and see if they match. So let's start with C. So I have one carbon or one letter C here. And if I look at how many C's I have on the other side, I also have one, right? So that matches out, right? Let's count the H's next. So notice that I have 4 H's here, but I only have one H here, right? So here I need to get to 4 H's. So what I'm gonna do is I'm going to draw this however many times I need that H. Right, so now I have a total of 1, 2, 3 H's, 4 H's. And just like we did in the example at the very beginning, I'm basically drawing these out like so as I'm adding them. Right, so if it counts out how many H's I have on the product side now, I have 1, 2, 3, 4. Right, so therefore I have a total of 4 HCl's. Right, so I checked my C's, they match. I checked my H's. I have 4 on this side and 4 on this side now. So now let's check my Cl's. My reactant side, before the arrow, I have 2 Cl's written in this orange subscript 2 here. If I count how many I have on this side, I have 4, 5, 6, 7, 8 Cl's. So 2 here, a total of 8 after the arrow. So therefore, I'm going to keep adding Cl's until they total up to 8. So Cl2 plus 2 is 4, 6, 8. Excuse the messiness of the boxes. So 2, 4, 6, 8. So how many times did I draw each box? Well, I drew it 4 times, right? And if I double check everything now, all of my elements should match, and this is the exact same answer as when I did this before. So 1, 4, 1, 4, doing it the mathematical way, the guess and check method. And if I draw out each molecule and then check within each box to make sure the elements match, I still get the same answer, 1, 4, 1, 4, right? So this is the method of drawing things out. Either way kind of works, right? Not kind of works, either way works, right? So it's up to you which method you choose. I'm gonna do one more practice problem showing both methods. Feel free to skip the second half of the video if you feel like you're ready to balance equations on your own at the end of this. Okay, so let's do one more if you're feeling stuck, and this time I'm going to use the guess and check method. The first method I showed you where we multiplied. Okay, so same thing as before, I'm going to split up my reactants and my product side. So reactants before the arrow, products after. Then I'm going to count up the number of elements on each side. So here I have V. Subscript is not written, so it's 1. Then I have capital F, so the element F, 5. In this molecule, I have capital H and capital I. So H, subscript is not written, so I have 1. I, subscript is not written, so I also have 1. I have the same elements on the other side, V, F, H, and I. So let's count out how many V's I have on the product side. So 2, F is 1, H is 1, I is 10. Right, so notice that H's match on both sides, but I's, F, and V do not. It doesn't matter which element you pick first, F, V, or I. It's totally up to you. Right, but I'm just going to start from top to bottom, starting with V. Right, so there's more V's on my product side than my reactant side. I have 2 on my product side, so I want to make it 2 on my reactant side. And the only way I can do that is by changing my coefficients. So I need to think 1 times what will give me 2 to match the other side. Well, 1 times 2 is 2. So that's how I get 2, a total of 2 on my reactant side. And notice that within this molecule, since there's no spaces, there's also F. So I also needed to fix F. So 5F times the coefficient 2 will give me a total of 10 Fs or fluorines. Right. So since this is not equal and I have less Fs on this side, let's fix this side. So again, thinking to myself, this 1F times what for the coefficients would equal 10 to match the other side, this 10. All right. So 1 times what equals 10? Well, 1 times 10 equals 10. So I'm going to have a total of 10 Fs. And know that this is also going to change my number of H's in the same molecule. So 1 times 10 will be 10. So for my H's, if I times 10 from this, I will get 10 H's as well. Right, so now my H's are no longer balanced. How frustrating can that be? But we're just going to keep going, and then it magically kind of works itself out at the end. Right, so now it's like, oh, 10 is messed up, or H is messed up, right? So then I need to ask myself, okay, if H is messed up, this 1 from H for the subscript times what's in the orange box will give me a total of 10 to match the other side. Right, so in this case, let me fix this to pink. So in this case, 1 times what equals 10? Well, 1 times 10 is 10. Right. So finally, notice that, hey, capital H and capital I are part of the same molecule. There's no space bar or anything. So therefore, it's going to be 1 times 10 for I will equal 10 I's. So by fixing H, I also magically fixed I where they have 10 on both sides. So if I check my elements from the reactants to the product side, they're all equal to each other. So my coefficients are going to be 2, 10. The blank means I just have 1, and then 10. Okay, so let's do the same problem, this equation, and try to balance it. But this time we're going to use the drawing method. And you might notice that since our answer was pretty large last time, right, it was 2, 10, 1, 10, that we're going to have to draw a lot of these, right? So that is the one downfall of the drawing method, is that you have to draw things over and over again. And sometimes it gets kind of frustrating. Okay, step number 1 is done. I've drawn out each elements below the equation, representing the fact that I have 1 of each in these blanks. And remember, if we have just 1 of each, you don't really need to write the number 1 in the equation itself. Step number 2, draw a line separating the reactant and the product side. Zoop, done. Step number 3, pick the elements on the reactants or the product side. Count the subscripts to see if they are equal. So let's just start with the first elements on the left here. I have elements V. So V subscript is no number, so I just have 1. How many V's do I have on this side? I have 2 in pink on this side. So therefore, I'm going to have to draw another one of these boxes, VF5. So now I have 2 V's on my reactant side, 2 V's on my product side. So I might also notice the second elements. How many F's do I have total now? Well, I have 5 from here, 5 from here. So a total of 10 F's on my reactant side. So I need to get 10 F's on my product side. So I'm going to draw HF until I have 10 F's. So 1, 2, 3. Okay, so I drew HF 10 times. So now I have 10 F's and 10 H's total. All right, so now my F's match, 10 F's on the product side, 5 and 5, make 10 together. So 10 on the reactant side. So I have 10 H's on the product side, but only 1 on the reactant side. So therefore, I'm going to have to draw 10 H's on the reactant side. Okay, so here I drew 10 H's on the reactant side. So now my H's match. 10 on the products, 10 on the reactants. Lastly, I have I. I have 10 I on the product side, and oh, look at that, 10 I's on the reactant side. So if I double check everything, 2 F's here, or sorry, 2 V's here, 2 V's here from the subscript. 5 plus 5 is 10 for F. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10 F's here. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10 H's here. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10 H's on the product side. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10 I's on the reactant side, and 10 I's on the product side. So how many of each did I use? I have 2 boxes of VF5. I have 10 boxes of HI. I have 1 box of V2I10. And I have 10 boxes of HF. So I end up with the answer that I got just before, right? This is a slightly different way of doing things, but it will get you the same answer. The only thing is, if the numbers are large, you have to draw a lot, which is kind of annoying, right? So either method works. At this point, you should be able to do the quiz questions at the end of the slides.